Hi everybody, Teacher M here. Today we're talking about alkanes. This is a branch of organic compounds containing carbon hydrogen atoms in tetrahedrogeometry. So for example, you have the smallest alkane here. It's gonna be the methane with 1 carbon, ethane with 2 carbons, propane with 3 carbons, butane with 4 carbons, pentane with 5, hexane with 6, hept 7, oct 8, and so on and so on. We go up to the 12 carbon in nomenclature for a general survey organic class, okay? And the alkyl groups, these are just part of the alkene chain. So like you lose 1 hydrogen from ethane, you get methyl. You lose 1 hydrogen from ethane, so that you branch it off from a long chain, you get ethyl. 3 carbons of a substituent is propyl. Isopropyl has this geometry. You have 3 carbons in it, that's why it's propyl. This is butyl substituent, isobutyl. You have 4 carbons and it's symmetrical, so it's iso. Sec butyl, you have the methyl group close to the parent chain. T-butyl, it looks like this. I always make fun and say it looks like a chicken foot. You have a pentyl, you have isopentyl, you have hexyl, isohexyl, because these are the most common substituents, okay? Alright, so just to go into the lesson, so you have the smallest hydrocarbon alkane is gonna be methane, right? That's methane. All I want you to know is the Lewis structure. The Lewis structure around a carbon. A carbon is always bonded to 4 other things, 4 other atoms. So that's the Lewis structure. So this molecule here, can be written differently. This one here can be written differently. It still can be written as bond angle formula, just like that. So no hydrogen atoms shown. So this is the bond angle formula. Okay, that's the bond angle formula. So I'll be using the bond angle. Formula throughout this lesson. Moving on. So to name alkanes, you have major rules. The naming is called nomenclature, which is a system of naming, and it's by the International System of Naming called UPAC. The UPAC naming of alkanes follows these main rules, where the alkane will have a prefix alk and a suffix ane, where alk part depends on the number of carbons. If you have branching, it has to pop out of the longest carbon chain. Each substituent is given a name and a number, the smallest number on the longest chain, parent chain. If you have 1 substituent, you need to number the carbons in the longest chain to give the substituent the lowest or the least number value possible. If you have 2 or more substituents, list them in alphabetical order in the name, but you still have to number them such that to give the substituents the least number possible. We'll look at more rules as we do this. So let's do this example of naming this alkane. What I always like to do is to determine the parent chain, because this is the longest, that's the longest chain, so you expect it to be the parent chain, right? So this should be the substituent. This guy here is the substituent. That's the substituent. and this is the longest chain. That's the longest chain. So we're going to number this longest chain's carbon such as to give the substituent the least number. So let's start in red. 1, 2, 3, 4, 5, 6, 7, or 1, 2, 3, 4, 5, 6, 7. Bottom line, you see those are the two numbers you need to judge, 4 and 4, so it doesn't matter which system, starting from the left or starting from the right. So if you start from the right, it's still gonna give you a 4. If you start from the left, the substituent still at 4. Whichever numbers naming system you choose is gonna be okay. But what is the name? What's the name of our substituent? What's the name of our substituent? This is an isopropyl, and for this one we're gonna make sure we take care of the alphabet I. So the isopropyl is on the 4th carbon, so the name's gonna be 4-isopropyl, and then we have the longest chain having 7 carbons. There's no double bonds, all single bonds, so it's an alkane. So it's gonna be hept for the alk part, and A and E to define that it's an alkane. So this compound here is 4-isopropyl heptane. 4-isopropyl heptane. Okay. So let's name the next one. Again, it's gonna be our longest chain. That's the longest carbon chain. That's the longest carbon chain, and that means that's a substituent, and it means this is a substituent. So I would again go ahead and determine the type of substituent. That's an ethyl. It's ethyl because you have 2 carbons. You have 2 carbons in there, so it's eth. It's eth because you have 2 carbons in there. And this one only has 1 carbon, so this is meth, but it's gonna be methyl because the substituent we use the suffix yl, but it has 1 carbon, so it's methyl and ethyl. Numbering the longest chain. To number the longest chain, let's start from the right. 1, 2, 3, 4, 5, 6, 7, 8, and then let's start from the left. 1, 2, 3, 4, 5, 6, 7, 8. 8 carbons, so it should be an octane because there's no double bond in the longest chain. Now we know we have the ethyl. We know we have the ethyl in blue, numbering on carbon 4, and we have the methyl in carbon number 5, versus having the ethyl in red on carbon number 5 and the methyl in red on carbon number 4. Now you see, it's hard to make a judgment which system to follow here because both of them is 4 and 5, 4 and 5. If you sum up, this is gonna be 9, this is gonna be 9, and because we're looking to get the least number possible, if you do the sum, you can tell which system to go. Both of them have a sum of total of 9, so we can't tell. So the rule here, you have to judge based on alphabet, basing on the alphabet, because you can't judge where to start from. If you start from the red, from the right, you get a 4 here, meeting the first substituent. That's the least number. If you start from the left in blue, you get a 4 for the ethyl. So you have to base on alphabet. And basing on alphabet, the ethyl comes, E comes before M in the alphabet. So we choose to give the ethyl the least number possible. So the correct numbering system is gonna be the blue because it gives the E ethyl the least number possible based on alphabet, because we couldn't judge based on numbering. So now the name here is gonna be for position of the ethyl, for ethyl hyphen 5-methyl. Okay, and then we have a parent chain containing 8 carbons, so it's octane, a methyl octane. I think we have a hyphen somewhere there. Okay, 4-ethyl 5-methyl octane, that's the name. Next, now here we have again the longest parent chain, but now you see you could start numbering from here: 1 2 3 4 5 6 7 8. So it's still an octane, or 1 2 3 4 6 7 8, still an octane. Substituents, you have the ethyl and we have the methyl. Okay, in this case you have the ethyl, carbon number 4, and methyl, blue numbering system, methyl on carbon number 6, versus having the ethyl on carbon number 5 in the red numbering system, and the methyl on carbon number 3. So these two guys gives you a total of 10, while these two guys give you a total of 8. So which means this is the right system because it gives you the least numbering possible. The sum here is 8, sum there is 10. So we follow this system because it gives us the correct least number possible for the substituents. So naming, the name of this compound is gonna be, still we're gonna put the E first in the naming, in the actual name, because E comes before M, but we judged the numbering system based on the sum of the numbers of the values given to the carbons of bearing the substituent. So this is gonna be 5, then ethyl, 3 methyl. See, E comes before M, even though 3 comes before 5, but you're basing on alphabet here. So it's 5 ethyl 3 methyl, 3 methyl octane, because we have 8 carbons in the longest parent chain. Okay, so we use the least number set of rule. So here we use the least number rule for the substituent to get the name, and not the alphabet like previously. Next one, longest parent chain, you have to follow the carbons. Even though they curve, you still have to follow them to get the longest chain number, longest carbon skeleton. So 1 2 3 4 5 6 7 8, or 1 2 3 4 6 7 8. Notice that that's a methyl, and this 2 is a methyl right here. So you can make your one this or that, doesn't matter. It does not matter. It does not matter. And this is not a substituent. This is not isopropyl. It's part of the longest carbon chain. All right. So again, we know our substituents. You have the ethyl again, and the methyl. So based on our blue numbering, the ethyl carbon number will come number 4, and the methyl carbon number will come at 7, and the ethyl in red has a number 5 carbon number, while the methyl in red has a carbon number 2. Doing the sum, if you want to do the sum of these two, you get 11. The sum of these two, you get 7. So using the least least carbon number rule, least carbon number rule, we find that this is the correct set and this is wrong. So we need to adapt the numbering in red. So all these guys are wrong in blue. So that's wrong. Alright, so our name for this compound based on alphabet, again, E comes before M, so it's 5-ethyl 2-methyl, and then octane, because it has the longest parent chain, has 8 carbons and it lacks double bonds, so it's ANE octane. Okay? So we use the least number set rule to get our name for that. Here is different. You have a ring, on here, and you have a long chain containing many carbons more than what we have in the ring, so the ring is gonna be a substituent again. So the rule here is that when you have a chain that has more carbons than the ring, then the ring becomes the substituent. So here we'll take the ring as a substituent. Why? Because it has few carbon atoms than the chain. Okay, it has few carbon atoms than the chain. So what ring is this? This ring by itself is cyclobutane. By itself it's cyclobutane. So since it's a substituent, it's gonna be cyclobutyl. And now, so since we want to give our substituent the least number possible, this is the way to do it. You start by numbering that carbon, because the closest one, this carbon is the closest one to the ring. That's the carbon closest to the ring. So that's 1, 2, 3, 4, 5, 6. So the name of this compound is gonna be, starting with the position of the substituent, it's gonna be 1, name of the substituent, cyclobutyl, and then the parent chain, hexane, hex, because you have 6 carbons. Okay, so again, the ring has few carbons than the chain, so it becomes a substituent, and it's cyclobutane ring, so it becomes, since the substituent is cyclobutyl and it's attached on the first carbon, that's the least carbon number we can give, versus giving this carbon number 6, so the name becomes 1-cyclobutyl hexane. Okay, so I guess now you are seeing these guys are so easy to do. So the longest parent chain here, you can start from either side. You can say 1, 2, 3, 4, 5, or start from this carbon 1, 2, 3, 4, 5. Let me choose the upper system of numbering. Okay, if you choose to do this 1, 2, 3, 4, 5, you're gonna get your substituents, which is that and that. This is the ethyl and this is the methyl. So you're gonna get, in blue, the ethyl will have carbon number 3, the methyl will be on carbon number 2. The ethyl in red is gonna be on carbon number 3, the methyl in red is gonna be on carbon number 4. Okay, so these two guys will give you a total of 5 for the set. Okay, so this is the set total, and this is gonna give you a set total of 7. So this is the wrong way because it has a bigger total value of the set for the carbons bearing the substituents, so we adapt the naming in blue and erase the naming in red, because this is now wrong. Okay, so now based on alphabet, ethyl comes before methyl, that's on carbon number 3, so it's gonna be 3 ethyl, 2 methyl, 3 ethyl, 2 methyl, and you have 5 carbons total, so it's gonna be pentane. Pentane, 2 methyl, pentane. Okay. Alright, 3 ethyl, 2 methyl pentane. Moving on. So for this molecule, you have so many substituents, but the rule is that you number the longest carbon chain with most substituents. Okay, let's use the green to give one numbering system. 1, 2, 3, 4, 5, 6, 7, 8. Let's use the red. 1, 2, 3, 4, 5, 6, 7, 8. And let's use the blue. 1, 2, 3, 4, 5, 6, 7, 8. Then let's use the black. 1, 2, 3, 4, 5, 6, 7, 8. Now the black numbering and the green numbering is wrong, because these two guys only gives you 3 substituents, while this guy's gonna give you 4 substituents. Why does the red, black and green give you 3 substituents? Because if you go with the black or green, the isopropyl will be 1 substituent. That's the isopropyl. It's gonna be 1 substituent. And the 2 methyls, those are 3. But if you go with the red and blue, you have the 2 methyls. You will take this ethyl as a substituent, that's 3. And then you take one of these methyl as a substituent, that's 4. Right? So the blue and red wins out of the set of 4, so we get rid of those 2. Then we're gonna get rid of either the blue or the red, so that's wrong. So now between the blue and the red, who wins? So with the blue numbering, you have a methyl, you have a methyl, and another methyl, and then an ethyl. So you have a methyl, you have a methyl on carbon number 4 and carbon number 4, because they are sharing the same carbon. These 2 methyls are sharing the same carbon. And then you have another methyl on carbon number 7 and an ethyl on carbon number 6. You sum these guys up, you're gonna get 21. Okay, you get 21 for the total. Now what about the red numbering? For the red numbering, you have a methyl on 5, you have ethyl on 3, and you have another methyl on carbon number 2. The red numbering gives you a total of 15. So that tells you the blue numbering is wrong. So we're gonna take the red numbering because it gives the least number of carbon sets. Total sum of the numbers of the carbons in the sets is less with the red numbering than the blue numbering. So it's 5, 5, 2, 3. So from that point we go with alphabet. E comes before M, and it's on the 3rd carbon, so it's gonna be 3 ethyl and then we have 3 methyls. So you define each of those positions singly. Because there are 3 methods, we use tri-methyl octane. Now one of this octane, because you have 8 carbons. One of the problems students sometimes get tricked on is this tri. Whenever you have a tri or di or tetra, don't consider the T in the alphabet. Here the only alphabet you're considering is the actual alphabet bearing the substring, the E and M. Okay, that's good. So let's do next. So for the next one, the longest carbon chain will be 1, 2, 3, 4, 5, 6, 7, 8. So it's an octane. Orange blue, 1, 2, 3, 4, 5, 6, 7, 8. And so which one will give us what we want? Which one will give us what we want? Blue or red? So it's gonna be the red numbering, because you have a 4 and 5 to judge on. So the red will win because 4 is less than 5. For the substituent, by the way, this substituent is isopropyl. So we get rid of the blue, and the name is gonna be for isopropyl octane. Okay, good. Now for this molecule, sometimes I see students taking this as a substituent. We know that whenever you have this substituent, that's a butyl. But the problem is it's at the end of the chain. So it's not a substituent. You have to go through it to get the longest chain. So the longest chain in this case is 1, 2, 3, 4, 5, 6, 7, 8, 9 in red, or 1, 2, 3, 4, 5, 6, 7, 8, 9 in blue. So here the best system of numbering is gonna come from the sets, the total number of the sets. So in blue carbon numbers, you have a methyl, 2 methyls. In fact, you have a methyl on carbon number 2, another one on the same carbon, and you have another methyl on carbon number 7, another metal on carbon number 7. So you have 2, 2, 2, 2, 7, and then you have an ethyl group on carbon number 4. Total, it's gonna be, let's see, 11 plus 5, this is 15. And then for the red numbering, red number system, you have a methyl on carbon number 8, another one on carbon number 8, you have another one on carbon number 3, so 3, 8, 8, and you have the ethyl on carbon number 6. Total 16 plus 9, 16 plus 9, what's that, 25? I hope it's 25. So that's 11 plus 14 is 25. So the red numbering is so big in the total. So we won't follow the red, we're gonna follow the blue. So get rid of that, get rid of the red numbering, get rid of the red numbering. So we take the blue numbering, and the name's gonna be following alphabet is 4-ethyl, because the ethyl is on the 4th carbon, but E comes before the M. 4-ethyl, 2, 2, 7, because you have 3 metals, gonna be tri methyl. Then there are 9 carbons, so it's nonene. Again, be careful, don't use T when considering alphabet. You are only considering the E and the M for the alphabet. Okay, so by now you know the rules, so let's go quickly. It's 1, 2, 3, 4, 5, 6, 7, following the red, following the blue. 1, 2, 3, 4, 5, 6, 7. Now if you decide and do the green like this, 1, 2, 3, 4, 5, 6, the green is gonna give you the least number of substituents. So the correct numbering is either gonna be the red or the blue, because the green only gives you one substituent with a sec butyl as a substituent. So this one of this is correct. So let's see. So for the blue numbering, you have methyl on carbon number 3, and you have an ethyl on carbon number 4. For the red numbering, you have a methyl on carbon number 5 and ethyl on carbon number 4. Total, here you get 7 and here you get 9. So the correct system of numbering here is gonna be the blue, because it gives you 4 ethyl, 3 methyl, heptane, gives you the least numbers. So 4 ethyl, following alphabet, E comes before M, 3 methyl, 7 carbons, heptane because there's no double bond. Okay, so let's look at naming cyclic alkanes. Cyclic alkanes. So naming cyclic alkanes, and they're gonna have substituent on them. They are cyclic because you see rings with given number of carbon atoms. Now whenever you have three substituent on the ring, you want to go with the least set of numbers from a numbering system. So for example, blue is gonna be 1, 2, 3, 4. That's the red, gonna be 1, 2, 3, 4, and the blue start numbering maybe from this method, 1, 2, 3, 4. Okay, and again I'm gonna do a very wrong one for the green, 1, 2, 3, 4, or even one more for the black, going clockwise, 1, 2, 3, 4. So let's find which is the correct number system. Starting with the black, the substituents that we have, which number have I not used? Which color have I not used? Okay, let me just write the substituents here. You have the methyl. You have 2 methyls on the ring, methyl, and you have an ethyl, right? Because that one here is an ethyl, and these 2 are methyls. Methyl. So following the black numbering, the sets that you have for the ethyl is gonna be on carbon number 1. The 2 methyls is 4 and 2. Okay, following the green numbering, you have 1 methyl having a 4, another methyl having a 2, and the ethyl having a 1. So those 2 have the same thing, Then following the blue numbering, you have the methyls on 3 and 1, and then you have, let me see, yeah, you have the methyls on 3 and 1, and then you have the ethyl on 2, following the red numbering. So following the red numbering, you have 2 methyls on 1 and 3, and then the ethyl on 2. Okay, so let's do the totals. So for the total here is 6. The total here is 7. The green and black number system is wrong, so that's out. So now, how do we judge which one is correct? Because both of them have 6 and 6. Okay, so for the red and blue, because you have your substituents having the same numbers, because the method here is the same as the method there, it doesn't matter where you start from. You can take this method as number 1, this method number 2, because ethyl is always going to be in the middle. So these two are correct. You can name using either the blue numbering or the red numbering. Either of those is fine, because the molecule has some sort of symmetry in it. We'll talk about that whenever we're talking about symmetry and carbons. Alright, so let's just give the name based on blue and red. So the name based on blue, the name based on red is gonna be following alphabet. So it's still 2-ethyl, and then 1,3-dimethyl. And because dimethyl, let me correct the name here, dimethyl. And because this is a ring, it's a cyclobutane. You have 4 carbons, 1, 2, 3, 4, and it's cyclic, so it's cyclobutane. So that's the name we need here, cyclobutane. Okay, for the blue is the same thing. It's gonna be 2-ethyl, 1,3-dimethyl cyclobutane. Okay, so that's how you name this compound here. Okay, next one. How do we name this cyclic ring? For one, we know it's a 6-membered ring, and there's no double bond in it, so it has to be cyclohexane. So let's find how to number this to get the right name. So it's 1, 2, 3, 4, 5, and 6. Or you take the red. 1, 2, 3, 4, 5, and 6. Or you go with the green, starting from the ethyl. 1, 2, 3, 4, 5, and 6. Or you go with the black. 1, counterclockwise, 2, 3, 4, 5, and 6. So same way. So now let's judge. So you only have 2 substituents. You have a methyl and you have an ethyl, and you have 3 color codes to judge from. 4 color codes to judge from and find the total. So I'm gonna go with the red first. Let's go with the red first. The methyl is gonna be on carbon number 1 and the ethyl is on carbon number 3. Okay, going with the blue, the methyl is on carbon number 1. Blue, methyl is on carbon number 1. Ethyl is on carbon number 5. Okay, going with the green, the methyl is on carbon number 5, and the ethyl is on carbon number 1. Okay, going with the black, the methyl is on carbon number 3 and the ethyl is on carbon number 1. Okay, doing the totals, here is 4, 6, 6, 4. So definitely, just looking at this, you can see the blue and the green numbering system is wrong. It's just fine. So we're left with the red and the black numbering system. Red and black numbering system, so blue and green is out. So red and black. Now, the goal here, since these two guys have the same number system and we can't judge on the two, we go back to the alphabet rule. We have to number or name, give a name with alphabetical order. E comes before M, so we're gonna give E the priority, so we're gonna go with the black and not the red, because M comes after E. So here we're gonna follow, first we follow the set total rule, and now we're following the alphabet rule to give our judgment, to write the name. So E comes before M, so we're gonna prioritize. We'll adopt the black system because that gives the ethyl carbon number 1 and not the red system that gives the ethyl the carbon number 3. Call that a little bit confusing, but you have to practice this. So this is gonna be 1 ethyl, 3 methyl, cyclohexane. So the name of this compound based on the black numbering system is gonna be 1 ethyl, 3 methyl, cyclohexane. You must say cyclo because it's a ring. Okay, so here I'm just going to use 2 number sets that will give me the least numbers possible. If you want, you can find the rest of the number sets. So let's start over. Here I'm going to give you the least number sets that give me the least total of the 4 systems that can be written in numbering. So 1, 2, 3, 4, 5, 6. Or the blue start from the purple. 1, 2, 3, 4, 5, 6. That guy has 3 carbons, so it's a purple. This guy has 1 carbon, so it's a methyl. So which is the correct one? So let's write here methyl and let's write here purple and give the carbon numbers based on the color code we've used. This is gonna be the total. So you start with the blue numbering system. For the purple, carbon number 1, methyl carbon number 2. You use the red numbering system. The purple has 2, the methyl has 1. So both of them give you 3, 3. You can't judge from there, you can't judge from the total. So you go back to the alphabet. M, P. So M comes before P, so that means we're going to adapt the red numbering. So this is wrong because M comes before P in alphabet rule. Okay, so we adapt the red numbering. So we get rid of the blue. We don't need the blue anymore. So the name here is gonna be 1-methyl 2-propyl, and it's a ring, so it's cyclo, and it has 6 carbon hexane. So 1-methyl 2-propyl cyclohexane. Okay, so next, this guy, let's try numbering it. 1, 2, 3, 4, 5, 6. Definitely here you have to use the least set of numbers because you have more than 2 substituents. Or 1, 2, 3, 4, 5, 6, or 1, 2, 3, 4, 5, 6. Okay, so let's just use those 3 to get a judgment. The red will win here because it has the least set of numbers. So we get rid of all other crap. Can't believe I said that. That's not professional, Moses. That's an African laugh if you don't know about it. Okay, so the red, so it's gonna, the name's gonna be going with alphabet. E comes before M and P, so it's EMP, so it's gonna be 4-ethyl, and then 2-methyl, and then 1-propyl, and then cyclohexane. Okay, so it's 4-ethyl, 2-methyl, 1-propyl, cyclohexane. Good. In this case, you have 3 substituents. You want to have the least set, so definitely this is going to be the least set if you want to try it out. Now you know what I've been doing. So the name for this one's going to be 1, 1, 2, then trimethyl because you have 3 methyls, cyclo because it's a ring, hexane because you have 6 carbons. This ring right here is just the same as doing the 6 carbons because that's in this one here is in 3D. This is in 3D. So in 2D, yes, like that, it's just the same thing as that. Now numbering this with this least set is gonna be either this one in red or this one in blue. It does not matter because the molecule can be sliced into half. You have an internal plane of symmetry. 2, 3, 4, 5, 6. Now this system of drawing the same ring, this system, that's the chair. That's how it's actually conformed in real life because of geometry. You learn about that in the future. In a coming class I will show you. So definitely this is your carbon number 1 in red or in blue, it doesn't matter, and this is your carbon number 4 in blue or in red. So the name for this compound is 111 nope, let's start over. So the name of this compound is following alphabet. E comes before M, 4-ethyl, 1,1-dimethyl, cyclohexane, because you have all single bonds in the ring, there's no double bond. Okay, So for this one, you can start numbering either side 1, 2, 3, 4, 5. So here it's gonna be 1, 4, and these are the two substituents. Those are isopropyls. So you have to say di isopropyl because there are two. Cyclopentane, cyclopentane. Okay, just to caution you, if you had this kind of molecule, that looks so crazy, so definitely the right system of numbering to have the least set of numbers. Now, which one do you think we should adapt? Both of them have the same totals of carbon sets, so you have to use the alphabet rule. So you have to use the alphabet rule, because E for ethyl comes before A, B, C, D, E, F, G, H, I, comes before I in isopropyl. So we're gonna give the ethyl the least number possible, so we're going to take the blue numbering and not the red numbering. So the correct name will follow the blue numbering system, so it's gonna be 1 ethyl, and then 2, 4 diisopropyl cyclopentane, because it's a 5-membered ring. So it's 1 ethyl 2, 4 diisopropyl cyclopentane. Notice that whenever we are looking at alphabet, we just base on the E and the I, not the D. You don't base on the D because that's just di that says you have two of them. So it's E and I. We don't look at the D. Okay. So this molecule is different, okay? It can be drawn as what you have here as a chair, where you have the isobutyl group, because that one now you have 4 carbons in it. You have 1, 2, 3, 4. That's isobutyl, and you have a methyl. So you can either choose to number like this, in red or in blue, starting from the methyl. 1, 2, 3, 4, 5, 6. Okay, so let's find which one is correct. Number 1, it doesn't matter, both of them have a total of 4, so this does not help us. What will help us now to judge which system to use is the alphabet. I comes before M. I in isobutyl comes before M. So we want to give the isobutyl the least number. So that means the red system should be adapted because it gives isobutyl 1 instead of 3. So we cross out the blue, we go with the red. Okay, the other thing, you see the bonds are opposite geometry. Whenever you have a wedge, it means that group is pointing you. Whenever you have a dash, it means that group is away. If it's in plane, you have this guy pointing down and you have the methyl group pointing up. So that kind of geometry is trans. Whenever you have opposite orientation of substituents, we use trans. Whenever you have same side or same face orientation, we use the word cis. You'll see that in the next example. So the correct name for this is gonna be trans. You have to define the geometry, and then 1 isobutyl and 3 methyl, and then cyclohexane. So that's the correct name, complete name. So it's trans 1 isobutyl 3 methyl cyclohexane. For the next one, you have same face. You have same face geometry because you have two wedges, that means these guys are pointing on the same side. They're on the same side. So I'm gonna define this as C's. So we need to start with the C's definitely somewhere, because the two bonds, two geometries are on the same side, same face of the ring, either on the top both of them or the bottom or on both of them. Anyway, that's the least number set that you would get to save time. So here you have isobutyl, and here you have isopropyl. Okay, since I and I is the same and you have more than two substituents, so you have to go with the least number set possible, and once you follow the steps like we've been doing, you find this is the correct one. So the name here is C5 isobutyl 2 isopropyl 1,3 dimethyl cyclohexane. Pretty long name. Looks like my name. I have a very long name. I wish this was my name given by my parents. Just kidding. C5 isobutyl 2 isopropyl 1,3 dimethyl cyclohexane. Feel free to subscribe, bring more friends into this site, and suggest to me down there what you want to see next, or what you want tackled if it's not in my YouTube channel. And you guys be blessed so much. I wish you all the best in your academics, and subscribe. See you. Thank you.